Hello, welcome to this lecture video. So I'm teacher Malay, and let's talk about intuition, proof, and certainty. So in our previous video, so we presented this outline. So our, of course, main topic is problem solving and reasoning. So in the first video, we discussed inductive and deductive reasoning. So in this video, what we are going to consider is the second topic, the intuition, proof, and certainty. Okay, so let us discuss these terminologies according to whatever is discussed by Ruben Hirsch. So he was Professor Emeritus of University of New Mexico from 1997 to 2020. So he was a recipient of Chauvenet Prize and also Ford Prize, and he co-authored Mathematical Experience and Descartes' Dream, which won in the National Book Award in 1983. And he was also the author of What is Mathematics Really? So our discussion is the topic discussed in this book, What is Mathematics Really? So particularly in his chapter 4, he discussed intuition, proof, and certainty. So let us start with intuition. So according to him, intuitive is everywhere. So he cited as an example of mathematical intuition is the work of Ramanujan. So this is Ramanujan, an Indian mathematician. So if you watch the movie, A Man Who Knew Infinity, so you might know something about him. So he was an Indian mathematician who wrote a letter to Hardy, an England mathematician or an English mathematician who works also with number theory. So here, he was able to convince Hardy because he was not able to get a good education. Ramanujan has no good education or a degree, but he presented he presented some computations to Hardy, wherein the mathematical intuition there is that he knew that the answer is correct. On the side of Hardy, he also believed the computation, even if the proof was not complete. So it's just an explanation, but he believed whatever is written in the letter of Ramanujan. So that is what they call as mathematical intuition. So mathematical intuition for Ramanujan and also for Hardy. So just to have some other information about Hardy. So he was born February 7, 1877. So he died in 1947. So he was a leading English pure mathematician whose work was mainly in analysis and number theory. So in the book, so he made mention of this three definitions of intuition. So Hirsch said that intuitive is the opposite of rigorous. It means visual. It means plausible or convincing in the absence of proof. It means incomplete. It means based on physical model or on some special examples. This is also close to heuristic. So intuitive means holistic or integrative as opposed to detailed or analytic. So this is the example provided by, or rather the definitions given by Ruben Hirsch in his book, What is Mathematics Really? Okay, so an example maybe could be, for instance, if you're going to, or you are asked to add a number less than 500 and another number less than 500, of course, you know that even if without computation, even if without details, aside from saying that it is less than 500 and another is less than 500, then therefore the answer is less than 1,000. But we cannot conclude yet you do not have this intuition that it is also less than 500, because you have the intuition that it's it is less than 1000. Okay, next. How about for proof? So, Ruben Hirsch made mention of the old definition of proof. So, he stated that proof means test, to try out and to determine the true state of affairs. But he also mentioned in his book that there were actually two meanings of proof, and the other one is in practice and the other one is in principle. So the practical mathematical proof is what we do to make each other believe our theorem. So that is informal way of the definition of the proof, while the more formal one, this definition is about the definition in practice. While for the definition and the theory, so it is more formal, of course. It's a sequence of steps, each a strict logical deduction, or readily expanded to a strict logical deduction. So this is supposed to be, so he mentioned that it is a formalization, idealization, rational reconstruction of the idea of proof. And this was supported by other mathematicians like Aristotle, Bull, Peirce, Frege, Russell, Hilbert, and Judell. Okay, next, in the definition of the certainty, he made use of three examples. So, the first one is 2 plus 2 is equal to 4. The second one is the angle sum of any triangle equals to right angles. And the third one is he considered a more sophisticated example which involves a convergent infinite series. So for the first one, 2 plus 2 plus 4, his claim here was, how certain are you that 2 plus 2 is equal to 4? So let's say he also cited some other mathematicians in discussing this. Is it not that 2 plus 2 is equal to 0, or 2 plus 2 is equal to 3, something like that? And then, as mentioned by him, if we're going to relate it into a real materials or object, like the one he used is button. So 2 buttons plus 2 buttons is, obviously it is 4 buttons. So you can actually count the number of buttons and you are certain, you are sure that it is 4 buttons. But his idea is this: what if there is an existing like chemical reaction, like adding this two chemical to another chemical, and it will result to 0 chemical? So is it also possible that it would be like that? And then for the second one, the angle sum of any triangles equals to right angle. So in also discussing this, he mentioned about the fifth postulate about the two parallel lines, that it will never meet, but that is for Euclidean geometry. So what if now that we have also the higher geometry, the non-Euclidean, that at a certain point it will meet? So does it mean that the sum of any triangles equals to two right angles will also be untrue? So maybe it is true for a Euclidean math or Euclidean geometry, but it's not certain for non-Euclidean mathematics. And also for the convergent infinite series, so what he pointed out here is that if you're going to add now this infinite series, so it's infinite, so which means what number will you get? So does it mean the value that you're going to obtain is finite? because, or are you certain that that's the answer? It is because we are talking about infinite series, which means it is unending. So why show a value that will represent a finite number? So the idea here of Ruben Hirsch is that it may be certain in a particular context, but it can also be uncertain if you're going to consider others. So you have to be specific, maybe. So for instance, for 2 plus 2 is equal to 4. If we are referring to real objects, then we are certain that 2 plus 2 is equal to 4. And other some concerns also is that what is plus, what is equal, what is 4. Are we certain that this is the meaning of plus? Are we certain that if we place the symbol equal sign, it means that you're going to do the operation plus? So something like that. So you are he's actually trying to make a point wherein it can be that you might think that you are certain, but in fact you are not. And also, we know that in mathematics, we must be certain, because in computing, for instance, for some problems, even if we use different strategies, we end up with same number. And we, of course, are must be, of course, certain that that number is answer to the given problem. So, for other or for more informations, for more explanations about these three terminologies, you can actually download the work of Hirsch, What is Mathematics Really? So these are the reference materials in this discussion. Thank you for watching.